Welcome to Subburaj Academy. You are attending a course on Introduction to Python 3 Programming. In lesson 9 now, we have completed 8 lessons so far. And in this lesson, we'll discuss in detail about a console output. You know what the console is. Console is a combination of the keyboard and the video monitor. We will discuss about printing or displaying things in the monitor. So that is a console output. It is not new. We have been printing various data types like strings, numbers, floating point, complex numbers, etc. But we will in this lesson give more facilities. Will discuss about more facilities of the print function. There is a syntax for the print function. So there are 4 things. The first thing is print. So you have to enclose parentheses, value or values. You can give any number of values and any type of value. But the value will be converted into a string by the print function. The second component of the format is sep, that is separator. Default is white space. White space can be space or tab. Okay. And the third and fourth, third is the end. At the end of the printing, what will you do? Here it is default is /n or a new line character. At the end of printing, the cursor will jump to the next line. There are 2 more. For the sake of simplicity, I will not discuss that. So always the values will be printed to a string before it's printed. We have been specifying commas. Okay, we will use commas for separating 2 variables, but the default is white space. We can always specify what we want to print at the end. Default is /n or new line character. Let us write a program to understand the printing in more details, following the format we just discussed. This is the program. The first line is a comment statement, the triple quote, and the second line, Ganesh is the string because it's enclosed within single quote. This is assigned to var1. See, on the left hand side, you assign it to what is on the left hand side. Karthik on the right hand side is assigned to var2. 27 is assigned to var3. And 15.5 is assigned to var4. Now we are printing print var1, comma var2, comma var3, and var4. Here the comma is separated between various variables. But when we are printing, we are saying sep is equal to comma. We are also saying that you separate the printing of variables using a comma. So what will be the output? The output will be Ganesh, comma Karthik, comma 27, comma 15.5. That's it. Of course, default is new line character. So the cursor will go to the next line. So there are other separators also. We saw only one separator. Okay. We can see we can have other separators. So in this slide is another program with the same 4 variables. And in the first print statement, we are saying separator is equal to at, and the end is equal to hash. So what will the output? Var1 is Ganesh at Karthik at 27 at 14.5, and the end has come, so you will have hash. You look at the last print statement. Here the separator is 3 dots. You can use anything, and the end is $. So the output is, because we didn't use a new line character at the end of the first print statement. So it will remain, the cursor will remain after 15.5. Okay, 15.5 and hash, because we have said the end is hash. So from hash, it will print Ganesh, 3 dots, Karthik, 3 dots, 27, 3 dots, 15.5, 3 dots, and finally it will insert a dot. So we have modified the printing as we like. So we will go for the form. So far we didn't give any format for the printing. You can call them as unformatted printing. Now we'll go for formatted printing. Look at the first statement on top. Print is followed by format. We didn't have the format in the previous print statement. So you start the format. Then within bracket we have a number followed by in single quote 6.2f. That has got a meaning. What is 6.2? The total number of digits will be 6 and this 2 digits after the decimal point. So it will print like this 4567.35. Here 0.35, two digits after the decimal point. And there are only 4 digits, total 6. So no problem, absolutely. The second print statement has format 6.3f, means 3 digits after the decimal point. But here the number, there are only 2 digits. So what you can do safely, you can add a 0. So it will print 567.350. So no violation. The total number is 6 and 3 digits after the decimal point. Look at the third print statement. It says print format a number 10.2f. But we count the number of digits, there are only 6. There are 4 digits, total digits can be 10. So it will leave, it will give leading space. So this statement will be printed with the right justification. Means you take total 10 positions and the whatever is printed will be printed in such a manner. The last digit 8 is on the 10th position. So it will print 123.68, leaving leading spaces before that. Look at the next print statement, that is 1, 2, 3, 4. It is 456.56, 7.3f. So 3 digits after the decimal point. So you add a 0 and you can print it. So far we have been giving sufficient spaces. What happens if the width specified is lesser than required? Suppose you want 10 spaces, but you are only giving 5 total spaces. Will it truncate the whole number? No. The printing will be exceeded. Okay, the format will not affect the printing, so nothing will be lost. The number's width is automatically increased by the Python system. So look at the last print statement where we have given 1, 2, 3, 4, 5, 6.679, but we specify only 8.3f. So it exceeds 8 spaces. So the full number will be printed without losing anything. So let us from this slide look at what is formatting in scientific notation. What happens if you omit f? So far we have been giving f, 5.3f, 7.3f, 10.3f, and so on. It prints a number in scientific notation by default. So if you omit f, what happens is it will print, if it's a floating point number, it will print in the scientific notation. You know what scientific notation? Number e to the power e and the number. So now we are printing format 456.56 and we have omitted f and we say 7.3. So what happens? It prints 4.57 E02. If you have put the F, then it would have printed full number 456.56. 0 it would have printed. Now it's simply 4.57 E02. It is rounded as a number, which is not desired. So don't omit the F. Okay. If you want to format a real number in scientific notation, we write E, the F in the format. Okay. There we are saying 1.3 F. Here you say 1.3 E. So now once you say that, you get a correct output. 4.566E, the 4.566E plus 02. Okay, this is more precise than the previous one. So we must include either F or E when you want to when you give the format. So next last statement, the print format, the number 10.2E. So what happens? The total width is more than required. So there will be leading spaces before the number. So I just mentioned about right justification. There's also left justification. Means you have a number and it prints. If it prints from the first position, that is left justification. Suppose it starts printing from little after some spaces, then it may be right justification. So far, what we have discussed are right justified, giving us a leading space if the width is more than required. Suppose you want a width of 7, but you give 10. So 3 spaces are extra. So it will right justify. If you want left justification, you may want left justification. No, I want it to be start from position number 1. Then insert a less than sign before the format. Okay. For example, print format 0.67, 10.2 percentage, not in percentage. Okay. Okay. Here, this is it will print 67.00 percentage. It's not left justification because again it will be right justification because there is no less than sign. The first print statement, there is no less than sign, so it is right justification. The second print statement, there is a less than sign. Okay, so it will print from first position. So print format, the same thing, 0.67 within quotes less than 10.2 percentage. So percentage is another format supported by Python. So it prints 67.00 percentage. It printing starts from position number 1. The previous statement, since we have not set the left, default is right justification. So it left extra spaces or leading spaces and then printed. So we can use percentage to when you want to print percentages. Instead of saying F or E, you put percentage, it will print the percentage. Okay, so far we have been talking about floating point numbers or real numbers. How about integers? So we want to print integers. So print format, first statement I'm reading, print format 457, 10b. 10b means 10 digits, 10 integer digits. What I want is only 3. So it will right justify leaving 7 spaces on the left. The next second print statement is the print format 45. We see always there is a format. If there is no format, the printing is unformatted. Okay. Print format 457 less than 66 means it will be left justified 6 positions and it will be left justified. Okay. So also note there were more important point here. The previous we said 10d means decimal. Here 6x means hexadecimal. So 457 will be converted into hexadecimal, which is 1C9. So that will be printed in the left justified manner. You can also print an octal number. So the third print statement does that. Print 457 less than sign means left justified. Okay, and 6 positions octal. So 711 is the octal equivalent of 457. 1C9 is the hexadecimal equivalent of 457 and 711 is the octal equivalent of 457. You can also print binary. So that's what the last statement does. Print format 457 10b means 10 digits a binary and it is right justified because there is no less than sign. So you see the answer 1111001. We can also format strings and then print it. In the earlier we didn't format any string. So to do that, you put format, then give what you want to print and the format. While printing strings, If you want right justification, you have to say greater than sign. Greater than 22 means total space is 22 and right justify. Less than 22 means is left justify, total width is 22. In the case of numbers or percentage, we never had to give greater than sign for right justification. But in the case of strings, you have to give it. So look at the first statement. So we are going to print wonderful weather, the total width of 22 and right justification. The second statement is total width of 22 for left justified. You see that W starts from the first position. What happens if you give the total width less than what is required? It will print the whole thing. It will not truncate anything. So as far as formatting strings concerned, we can use convention character yes to format a string. We can even omit it. We didn't give any yes in the previous slide. So to right justify, we use the sign greater than sign, and left justify we give less than sign. So the string is longer than the width specified. The width is automatically increased. No truncation. So now we will find another use of percentage as a placeholder. So look at the program first. The first two statements are comment statements. Then I'm saying name is equal to Saxena. The Saxena is a string and that is assigned to name. Second is another string assigned to here. Then I have str1 means a variable which is a string because you have got a single quote. Name is then percentage yes and here is percentage yes. Then percentage name comma here. What it means is you start printing name is the first percentage yes will bring the first variable that is Saxena. And here is percentage yes, you have to take the second variable that is here and then print. So this is how we give it. You give the string, insert placeholders percentage yes, then at the end of it you put percentage, then within parentheses you give name and the variable names. The variables have already been defined. If you give some other variable name, it won't. It will be an error. So you have to give variables here, list the variables here. And the first one is first variable, second one is second variable, and the third one is the third variable. Then we write print str1. So it prints name is Saxena and here is second. So this is a convenient mechanism where you can have placeholders for the variables. So we have inserted percentage wherever we wish to insert the variables. And the variables themselves are given in parentheses at the end of the string with the prefix of percentage. There is another method called str.format. You know what is str? What is str? Think about it. The str.format is one of the string formatting methods in Python 3. It enables substitutions. So the last slide also you saw substitution. The percentage yes was replaced with or substituted with variables and value formatting. It enables substitution and value formatting. The method lets us concatenate elements within the string through positional formatting. Even the last one was positional formatting. The formatters permit the formatters, that is what the format we give, the permitters to put one or more replacement fields and placeholders. Earlier we used percentage yes as the placeholder. We can use a pair of curly braces, means curly brackets inside the string. Instead of percentage yes, you can put curly braces. Then we have to call str.format. There we call only format, but here we have to put str.format function to print the strings and variables substituted. So these two methods, what we saw earlier, we have given percentage yes, and it is a placeholder. And whatever the variables you give, they substitute the percentage yes. Here you put a curly braces inside, and it is the placeholder. But in this case, we have to use str.format method because earlier we simply put format. Now it will be str.format. The values we wish to put in the placeholders and concatenate them with a string are passed as parameters to the forward function. In the last one, we were passing variables to the forward function. The forward function was inside the parent function. The value could be an integer, but there it can only be a string. But here the value could be integer, 20-point number, and string. You recall the percentage yes means string, but here when you put a curly brace, it insensitive to the type. And you know that strings are immutable. We know that strings in Python are constants, so they are not mutable. Now let's look at an example program for passing variables to the placeholders. So here you have the program. First two statements are comment statements. Then the variable name Saxena, here is second. Then you say str1, that's the variable. We put within double quote, you can also put in single quote. Name is curly brace, and here is curly brace. Now the change comes here, print str1 format, str1 dot format, name comma here. So you get the result, name is Saxena, and here is second. So we saw two ways of placeholder. The first one was percentages. Here we simply use the curly braces. In both the cases, it works well. So now we'll discuss about passing values to placeholders. So str1 is name is curly brace and double curly brace. Okay, that means there are two things we have to insert. Two curly braces, that means we have to do two things. And here again two things. Look at again str1. str1 has totally 5 placeholders. So it will print them, the next set will print the str1 format. Then we are giving 5 variables. So we are not storing separately, but here we are giving str1 format. So Krishna studying 4 at SR. So how it will print? It will print name is first curly brace Krishna, name is Krishna, and first the second curly brace name is Krishna, and studying is the second one. The third one is the fourth year. Fifth one is the fourth one is at, and fifth one is SR. So I'll repeat again. You start from name is, then the first curly brace comes, so it says Krishna. Then it's the types and. Then second curly brace comes, you put studying. Then third one, so fourth, studying fourth. Then year is typed as it is, printed as it is. Then at, then the last one SR. So that's how the whole thing is printed. So here you don't specify any particular format, you only put braces, and here you put str1 format, and then you str1 means this is the name of the string variable, and then you give all this, you get a printout nicely. The last two programs, the placeholders were empty. You remember the previous one, placeholder was empty. We substituted it when the program was executed. Python replaces the values passed to the format function, the placeholders in the correct order, right? Otherwise, you would have got a mistake. We can even insert the index of the index or positional order in the placeholders. So we had a empty braces as placeholders, the last one, and the previous one it was percentage yes. But here you can also give an index. So we can even insert the index or the positional order, the placeholder, instead of keeping them blank. This is better, isn't it? The values are passed to the format position. So again, you use str1 format or tuple data types, and each value contained in the tuple can be called by the index, which starts with 0. These index numbers can be placed in the curly braces that serve as the placeholders in the string to be printed. Look at the program. First two statements are commands, our positional arguments. With the str1 name is 0, that is 0th index, and one is first index, second index, year, third, fourth. Print str1 format Krishna is 0, 1 is studying, 2 is fourth, third is at present SR. Suppose you change this here, suppose you put 1 here. What will come? 1 will be studying. It will print studying. So this is more flexible. So these are called positional arguments in the format statements. So far we have been seeing different types of formatting and printing in Python. Now we'll look at there's a string module in Python. We had used string class str. We had also used string str is from string class. So we have been we didn't talk about module. We talked only about class so far. But there's a module in Python called string module and template class. So template is a class and string is a module. Okay, small letters or all lowercase string. The module has a class called template. There's a class called template in the string module. We can use template for formatted printing. It's very interesting. The class is used, which class? Template is used to create a string template for simpler string, for simpler string substitutions. This was proposed, Python has got ongoing enhancement programs. There is an enhancement proposal PEP 292. They proposed the template class and string module. The template class supports new rules for string substitution. Once a template class has been created, substitution can be performed. Let's look at an example to confirm what we discussed. So, comment. From string, you have to import template. From string module, import template class. S is equal to template. Note carefully. Start here. Dollar name was born in dollar country. End of quote. Close. Very carefully notice the format. Now, next statement is a little more complicated than the previous ones. Print S is what? The whole thing. S dot substitute in the string to substitute name is equal to Gandhi, country is equal to India. Okay, first time you are doing it. Print S substitute name is equal to Gandhi, country is equal to India. What will be printed? Gandhi was born in India. Gandhi, okay, Gandhi was born in India. So basically dollar name, dollar country are the variables. Then we can change that, whatever you have been doing, we want to change it. Then, we have second print statement. Okay. Here, template was born in country. The second template is template. This is the first template for yes. Second template, dollar name, place, dollar sports. So the first variable is dollar name, the second is dollar sports. S substitute, name is equal to Dhoni, sport is equal to cricket. Because Dhoni plays cricket. Okay. So I'm not changing the template, but I'm going to give another print statement. S substitute, name is equal to Viswanathan Anand, sports equal to chess. So it will print Viswanathan Anand plays chess. So interesting, isn't it? So you create a template and substitute the variables and print whatever you want to print. So this is interesting, but little more you have to import, then you have to specify a template, then you have to substitute and so on. Now I'll introduce you to what is called an fstring. I told you about Python enhancement proposals. These proposals are made in the Python committees. In the PEP 498, they introduced a new formatted printing methodology. It is for strings. It is commonly known as fstrings because of the leading F character preceding the string literal. So they proposed some methodologies for formatted printing of strings, for others called fstrings. The idea behind fstring is to make string interpolation simpler. But I'm not going to discuss or give example for this, but you know that there's something called fstring introduced by PEP 498. To create an fstring, you prefix the string with the letter F. Earlier we were not prefixing with F, we have to prefix F. and pass it to a print function. Now, this is a very interesting slide, but simple, nice. We want to check whether a string is a palindrome or anagram. What is the palindrome? NUN, none, is a palindrome because you read from either side, left to right, right to right, you get none. So, good example, Malayalam, in both sides, it will be Malayalam. You read from left to right or right to left, in Malayalam. So, check whether a given string is palindrome. That's the purpose of this slide. So, I have executed this in the idle interpreter. So, I'm writing if str1 equal to str1, that is called reverse. You read it from the reverse side. -1 means you from the reverse side you start reading it. If print f str1 is a palindrome. Print if str1 equal to str1 -1 means if whatever you read from the beginning to end, and then first letter, last letter, second letter, last but one letter, and they're equal, then you print if str1 is the Malayalam is the palindrome. So we use -1, that is colon -1 to reverse the string. What is the anagram? Anagram means it's not the same word when you read from left to right or right to left, but it contains the same characters. How do you find out whether two strings have the same characters? We can sort it out. So that is the second part of it. We are checking whether a given string listen is anagram or not. Listen and silent are anagrams. So to check that, sort str1 means from A to Z, and if a sorted str1 is equal to sorted str2, both are be sorted, then you will get same characters. What will be the first character? It may be E in both. Okay. Then maybe I in both, maybe. Then like that. So you sort the characters in ascending order in str1, sort the characters in ascending order in str2. If the sorted ones are equal, then print f str1 and str2 are anagrams. So see, we use f string. That is, we are putting f before the str1, str1, yeah, before the strings. F str1 and str2 are anagrams. So in this slide, we check whether two strings are palindromes or it is whether the string is palindrome and whether two strings whether they are anagrams. What is sequence type? Sequence type means you can access from using an index. We have not discussed a list so far. Anyway, it won't be that clear to you. So sequences allow us to store multiple values in an organized and efficient fashion. So two things, we organize the storage, and efficiently organize. The elements of the sequence can be accessed by indices. What index? For example, say name, NAME. If it's a string, the first character N, the index is 0. Second character index is 1, and so on. So elements of the sequence can be accessed by indices. Like in strings, you do that. Python supports 6 sequence types as given below. What are those? Unicode strings, lists, tuples, byte array, bytes, range objects. Of course, we will discuss about all of them in the future lessons. The strings, tuples, and bytes and range are immutable sequences, means you cannot change them. You replace it, but you cannot change it. Replace some element in string, but you cannot change it permanently. The string was the same. So they are immutable. The list and byte array are mutable sequences. You can change the contents of a list or a byte array. It will clear as we discuss more. The byte function returns a bytes object. Byte means 8 bits binary number, which is an immutable sequence of small integers that range from 0 to 256. The byte function returns a byte object, which is a sequence and immutable, means you cannot change the range from 0 to 256. Both sides, 0 is included and 256 is not included. They are printed as ASCII characters when displayed. The byte array returns a new array of bytes. Note that the byte function returns a bytes object, whereas the byte array, in contrast, returns a new array of bytes. The byte array type is a mutable sequence. See, byte function is immutable, byte array is mutable, means you can change. It also produces same sequence 0 to 256. The range type represents the immutable sequence of numbers and is commonly used for looping. We will see in the loops, we saw in the loops, we use range. So that is also a sequence, but this is the range of numbers and it's used for looping. So range represents immutable. The range you cannot change the values inside the range. We use the range when we discuss about the for statement. Remember? So these are the few sequence types whose elements we can access by giving a index. Say for example str0, str1, 3, and so on. So we come to the end of the lesson. So you have to carry out assignment 3 given the folder. Assignment 3 is 1.3. We call it 1.3. Carry out assignment 1.3 before you proceed to the next lesson. It's very important. You must carry out assignments so that you consolidate your knowledge. That's all for now. Until we meet again, bye bye.